Hello, good morning. Good morning, everyone. Thank you for joining us this morning to our Welcome to Solis product presentation. I am Carmen Dumitrescu. I am Product Solutions Manager for Solis. I've been with Solis now for 4 years, and I have a total experience in the PV market for over 8 years now. And we're here to share a bit of the knowledge and some good news, some new news, let's say. We're going to talk about new products, but also our older, well-established products that we have on the market. And I have with me here my colleague Per. Per, if you like to say a couple of words.
Yes, of course. Hi, everyone. I'm Per. I'm technical after sales and support in the north. So I'm covering Sweden, Norway, Finland, and Denmark. We have me in the north, and we have a salesperson also in north. And I live in south of Sweden. I've been doing PV and electrical work since 2017. So I've been in Solis for almost a year now. Welcome, everyone.
Yes, and we have been happy to have you, Per, because he has been such a tremendous support for all of our customers in the Scandinavian region. And not only, we work in Solis, we work as a team throughout Europe. Yeah, I think we should actually start and discuss about the products. We're going to go and have a short overview on what we currently have. Talk a bit about the Solis design tool, export power management functions and solutions that we have. A bit on the monitoring and commissioning, and also some processes for troubleshooting and RMA in case you encounter any issues. Per here, I'm gonna share the presentation and we're gonna go through it together. Per will be answering your questions in writing. You can see in the bottom of your screen to the right, you have the questions tab, and you will be able to type in there all of your questions that you have, no matter on the products, on the technical, and we're going to do our best to answer you directly. Everyone will be able to see the answers. Per, if you think there's any topic that might maybe at the end might worth mentioning or sharing for everyone, please let me know.
Sorry, Carmen, if you want to write in Swedish, that's no problem.
Yeah.
If you're not comfortable with English, write in Swedish.
Awesome. Okay, so let's dig in. Well, about Solis, I think we're not such a new player on the market. We have been on the market for starting with 2005, and we have slowly developed. Our first market in Europe was actually the UK market, and afterwards, slowly but surely, we actually nowadays, in 2003, we have been ranked as number 3 in the PV inverter manufacturing business, which has been quite awesome for us. And this is we have reached this top 3 only with the work of all of our colleagues. And also, I think it's proof that our inverters are quite reliable and appreciated around the market. Until now, we have delivered shipments of up to 40 gigawatts. That was up until the end of 2022. This value has exceeded. This is also because we have constructed a new manufacturing facility. It's our manufacturing facility is in China, next near, let's say, Shanghai, near the Ningbo area, where we have over 4,000 employees, a very big R&D team, which is actually investing quite a lot in the development of our project. Everything is built in-house, and I think this gives us quite a nice grab on the quality of the products. This is shown in the reliability of them. But now talking about the products, because I don't want to waste too much time. We have 1 hour here to go through everything. Well, everything, because Solis has started its business more in the residential market, and we have developed these products for the residential market since the beginning, and they're a big part of our portfolio, starting with the smallest ones that we currently have, from 0.7 kilowatt up to actually 10 kilowatts for single phase inverters. We have a single MPPT, which are the minis. We used to call them the minis. We have the S6 GR1P from 0.7 up to 3.6, and this M at the end will tell you that it's the 1 MPPT version of the product. S6 means it's the 6 series. GR stands for grid-tied residential inverters. So these are inverters which are dedicated for the residential sector and are grid connected. So they cannot work in off-grid conditions like our hybrids actually can do. But we're going to talk about them a bit later. We do have the bigger sizes from 2.5 up to 6 kilowatt. These are with 2 MPPTs. You see that they miss the M at the end, so this gives you a hint that there are 2 MPPTs, and we even have a 3 MPPT for those products which are dedicated mostly for the UK market, the ones from 7 up to 10 kilowatt single phase. All these have maximum voltage inputs of 600 volts. That is quite enough for single phase inverters. And you can see you can have maximum current input of 14 amps. It can also be 19 amps for the 3.6 with single MPPT, and this means that you can connect high current modules, which is super useful nowadays, because these are the power modules that are coming in as a trend for the big module market. If we are to talk about the 3-phase inverters, which can be for the residential but also for the commercial, we can start to talk about the S5 GR3P from 3 to 20K. So S5 is the 5th series of this product. These are grid residential 3-phase from 3 up to 20 kilowatt. These have 2 MPPTs, and you can see that they range. Within the range, they have quite a few. The sizes are quite varied: 3, 3.6, 4, 5, 6 kilowatts, 10, 12. This gives high flexibility when designing the systems. Then looking forward to the bigger commercial inverters from 25 up to 40 kilowatts is the S5 GC. GC stands for grid-tied commercial inverters. And then even further for the S5 GC 50 to 60 kilowatt. so even bigger. These can have up to 6 MPPTs depending on the size. All this information can be found, all this technical information can be found in the data sheets of these products. But the most important thing is that these have even higher current inputs, 32 amps per MPPT, and have a maximum voltage input of 1100. So this will allow you to have longer strings connected to these, but also higher input currents. Of course, I need to also mention the LV inverters from this product range. These are inverters which are dedicated for the Norwegian and Belgian market. These are the ones which are able to connect to the IT grids, where the voltage in between the phases is 230. We have the S5 from 3 up to 10 kilowatt. We also have the 25 to 40 kilowatt and the 50 and 60. All these, as you can see in their naming, at the end they have this LV, stands for low voltage AC grids, and can only be used in these type of grids. Going through the commercial, big commercial or very big commercial and utility scale, we have the products from Solis 80 to 110 kilowatt 5G. Nowadays we have the Pro version, which will actually allow you to connect on the MPPTs strings with currents up to 40 amps even. Depends on the module that you choose, either if it's a 5G or it's a 5G Pro. These have a rated voltage AC output of 400 volt. And for the utility scale, we have the Solis 215 to 255 EHV, 5G EHV. This stands for high voltage. This is because these inverters are designed to actually connect to AC grids with a rated voltage output up to 800 volts. And of course, in the utility projects, those will connect further to a transformer. And for these as well, the maximum current input is quite high, either 30 or 26 amps, depending on the type of the inverter, the size of it. Did I mention that? So we're not only going to talk about the grid-tied inverters, we're going to talk about the hybrid inverters as well, which are quite one of the most exciting sides of our portfolio. We have started quite a few years back with the single-phase hybrid inverters, where these were the RHI 3 up to 6 kilowatt, so quite small single-phase, 48 ES, meaning that they were able to connect to 48 volt battery storage systems. These have quite recently have been replaced by the S5 EH1B. It's the same size of inverters. It's just the naming that have been changed from the 5th generation 5G to S5. And this one also allows higher current inputs of 15 amps, opposite to the older RHI model, which only allowed 11 amp inputs. This one, the S5 version, still has this nice LCD screen, a colored LCD screen, but we have actually discovered that unfortunately not many and customers do actually use it. So in our future products, we will choose a much easier way to actually connect to the inverter. Also because these inverters are not always connected where you would want them to. There might be in lofts or in garages, so in places where you might not have easy access to these. So that's why for the next generation, the S6 for the single phase and for the 3-phase, as you can see here in this picture in the middle, we're going to have actually Bluetooth connection. So you're going to be able to have all the information available, usually on the screen, available to be displayed in real time on the Solis Cloud app, which connects either via Bluetooth for local monitoring or via, let's say, Wi-Fi or LAN, if you want to connect to the monitoring platform online. So starting with the single phase, then moving to the 3-phase. The 3-phase, nowadays, we still have on the market this very cool product, the RHI 3P, from 3 up to 10 kilowatt. This is compatible with high voltage energy storage systems, and it allows a maximum current input of 13 amps. The S6 series will have even higher maximum current inputs of 16 amps. And we also, this is a product that has been highly appreciated, and that's why we're going to have a new version for it. This is an AC coupled 3 kilowatt. So it's a single phase inverter, which will allow every customer who already has a PV inverter string, grid-tied inverter, but without batteries, if they want to add storage capabilities to their existing PV systems, they don't have to change their equipment altogether. They can only just have the RAI with a battery connected. This RAI will connect to the AC side, and it will collect the excess of energy that is not being consumed locally, and it will capture that energy and store it in the batteries, and it can be used later when it's needed. For example, when there is no PV anymore. Also, all of these products on the hybrid side, they all have backup functions, so they can work in off-grid conditions when the grid is not available, without the additional need for purchasing any other equipment, any boxes to allow connections of those critical loads that you want to supply when there is no grid. So as you see them, these products are ready to supply energy in no grid situations. So this is, of course, having a battery connected to it. And I think it's a very important aspect to mention. And what these hybrid offer as a flexibility is the fact that you are able to connect various battery types from a very long list of batteries which are compatible. These are just a few names that were thrown here on this, but we do have a very big list of batteries compatible. This list, you will always going to find it on our website, on solisinverters.com. And this is split nowadays. It's split in between the single phase, the 3-phase inverters. So for each type of batteries, for each type of inverter, we have a separate list of batteries which are compatible, of course, because they're either low voltage, as you can see here for the single phase. You can see the brand of batteries, which these have been compatible with, the exact models, and also the firmware versions that allows the inverter to actually be able to communicate with these batteries. All of these batteries have been tested and have been a special firmware has been developed for them and included in the standard firmware. So, for example, with the latest firmware available, you're going to be able to find in your predefined list for the inverter all of these, a list with all of these brands and all of these models to select from when you want to choose a certain battery for the design that you're working on. Always try and check this battery to have, so that you can have the latest one, because we are constantly updating it. Sometimes it's even updated once a week or once every 2 weeks. We're adding new batteries to these systems. It is very important for us that the customers do have the flexibility to choose from the batteries that are available on their market. So, for example, if one of our customers comes to us, for example, one distributor comes to us and tells us we have the request from our customers to for the inverter to be compatible with this certain type of battery, what we can do, we can get that battery, we can test it, we can create a new firmware for it and add it to our battery compatibility list. So I think it's a huge advantage that our hybrid inverter have. Now I would like to discuss a bit about the Solis design tool. This is something that we use. It's super easy and everyone can actually use it. It's an online tool where you can test a certain string design to see if it fits with a certain inverter that you want to. Actually, we do have, there are two design tools. We have the older one, which I still use, even if maybe I can't always find the latest PV modules, but I don't mind, because anytime I can add within the design tool, I can add any PV module that I want, and anyone can do it. Considering now the number of PV modules that are available on the market, it's almost impossible to always be, for such a tool to always be up to date with everything. So this design tool that I'm going to show you now, it's just by logging in with an email address, you can actually have access always to your whole list of projects that you have been working on. So always it will be there with you online. And you can create, or you can modify existing projects, or you can create new projects. And the only steps that you have to go through on this main page, let's just to set the location, set the inverter model that you want to use, so you can select from the list of Solis inverters. Then select the panel manufacturer and the exact module type that you would want to use. It will give you, let's say, a recommended number of modules per string, but these can be modified just so that it will suit your needs. So you can change this number, and it will tell you here on to the right. It's going to tell you if that specific design is actually is compliant with the maximum input values, for example, for current or for voltage or for short circuit current for this model. And also it will give you a value for DC to AC ratio. So the max, let's say the percentage, how much PV you have you have installed on the DC side. and the rated AC output power of the inverter. So these are, let's say, parameters that you might be interested in when designing. And at the end, if you're happy with the design, you didn't get any warnings, you can actually save the project and you can export a report. It will tell you also how much energy that current system can actually generate based on the radiation which have been defined for that particular location that you have selected. And that one you can even use to share it with customers or for yourself if you are an installer. I would recommend you to give it a go. I think in the very near future, it might be even next month, we're going to also organize, let's say, a short webinar just to discuss about the new design tool, just so I can show you how it works and how you can use it. Because I think it's something that everyone can use. Nowadays, now let's talk about export power management functions for our inverters and the consumption monitoring. So when would you need export power management? What does that mean? It means that there are certain projects, certain locations for which, for example, the grid operator will only allow you to export a certain amount of energy to the grid. That's because probably the grid might not be able to take all that energy that you're generating, or you're not even allowed to export anything to the grid. But what you can do, you want to actually use that energy locally. So that installation will have some consumers, some loads that are able to actually consume that energy locally. But what you want to do, you don't want to have any type of leakage of energy to the grid, which has not been authorized by the grid operator. So that's why you actually need, for this case, an inverter. Normally, when it's generating, it will only be able to tell you how much energy it's actually generating on its own, but it will not be able to tell you how much of that energy has been consumed locally, how much it is going out to the grid. But you need, when you are in this situation where you're not allowed to export, then you need to know how much is it actually going out to the grid, so that you can lower the generation for your inverter, so you can control either to ramp up or ramp down the generation based on the way your local loads are varying, the consumption of the loads are varying. So the only way to do that is to actually have a device which is connected at the grid connection point, so after your loads, and that one can actually measure if energy is going in or out from the grid. This information is sent to the inverter through RS485. So in this case, where we have just one device, one inverter connected to the grid, we can easily use a smart meter. Solis has a type of smart meters which have been specifically programmed to work and properly communicate with inverters. So there's no need for any additional setup on the meter side, only on the inverter side, just to tell it how much energy you are actually allowed to export to the grid. And based on that, the inverter will use this information coming in from the meter to control its output, so that that we call it backflow power. So that value that you have set for maximum export to the grid, shall not be exceeded. So it will try to adjust. It will adjust, not only try, but it will adjust its generation based on that value. So we have two solutions. One is for installations with just one inverter, either single phase or three-phase inverters, and these inverters will be connected to either Solis meter, or they're in some cases only for the UK market. We have a solution for actually, instead of using a meter, to use a CD clamp, but that's not available. It's only available in the UK, and it's based on how the actual inverters for UK are designed internally as hardware. So don't try to connect an inverter which has been produced for let's say outside UK market, to use it with a CD clamp, because it's not going to work. It needs an actual meter. But I thought it is extremely important to mention this, because you might see all this information also online or in the user manual, so that you'll know where and in what cases the solution applies. And the other solution that we have is for when you have multiple inverters, which are connected in the same grid connection point. And for this case, we will need not just one meter, we will need an EPM, export power management device. This is how we call it. We have several type of EPMs, EPM single phase or three phase, depending on the type of inverters you're connecting to it. And this EPM will act just like a meter. It will monitor the export of energy to the grid, but at the same time, what it will do, it will also control all of the inverters which are connected to it at the same time, and control their output, so that all of them will react at the same time to either lower their generation or increase their generation, just so that no excess of energy will go out to the grid, besides what you are allowed to, what you have set up as maximum output. So I was mentioning, just going real quickly through these meters. I told you for UK there are CD clamps, but for the other installations where you have an inverter, you'll have these acrylic type meters. This is the brand. I would not encourage these to be purchased from somewhere else, because as I mentioned earlier, these meters that we deliver have been already preset and have all the settings already pre-made on them, so that they can work correctly with the inverters. Some of them have direct connections. Some of them come with with CD clamps to measure the current, and you have all the CD ratio settings, for example, already preset there. You have all the communication addresses, and also settings for the Modbus communication to properly communicate with the inverter. So everything is all set up with the meter that we deliver. If you purchase them from somewhere else, that probably is not the case, and you're going to have issues for communication between the inverter and the meter. So I was saying these can be either single phase or three phase meters. They can have direct connections, or they can have CD clamps. The CD clamps that they come with, they can measure up to 150 amps. They can measure, up to 150 amps, and they have a 5 amp secondary current. The direct connection meters have a limitation because they can only measure up to 80 amps. So if you are using them in installations where the current flowing through the grid connection point is higher than 80 amps, then I would recommend you to use the meter type with external CDs, because it will allow higher current. Also, the location of the meter can vary. You can actually install this meter either on the load side, so it will measure what the loads are consuming, and it will, based on that, the inverter will actually try to match it. For example, if you have a zero export scenario and you have set zero backflow power for the inverter, what the inverter will do, it will match its generation with the actual load consumption. But then this is where, when you have the meter set in load. When you have the meter set in grid, then it will, the logic will change a bit, and the generation of the inverter will match. Actually, the backflow power of set for the inverter will have to match the output power measured here at the grid connection point. So this is the solution for installations with just one inverters. But when I said when you have multiple inverters, you're going to need a EPM, Export Power Manager device. We have 3 types of these devices: Solis EPM 1G, 5G. This is a single phase EPM, so it will be compatible with single phase inverters. It can control up to 10 devices connected through RS485 to it. Then we have Solis EPM 35G. These are inverters. This is an EPM which is compatible with 3-phase inverters, can connect up to 60 devices. And both of these, EPM 15G and EPM 35G, is compatible with our Solis data loggers, meaning that if you want to send out further the information to the monitoring platform, you can connect any of the Solis data loggers to them, and it will send out the data. And we have the third model. Currently is the Solis EPM 35G Plus. This Plus version actually can connect up to 80 devices, 80 3-phase inverters. It also has an internal meter for higher precision, and also has a built-in data logger. So you don't need an external data logger to add to it. But this device has an older type of data loggers, which internal data loggers. It's a SolarMan type data logger, and it doesn't offer, let's say, the all the perks that the Solis data loggers bring. So this is why in the near future we're gonna replace this device with actually a Pro version, and this Pro version will come. It will be, again, it will have a meter with for high precision measurements, and it will connect to a Solis data logger, an external one. This is how the setup, let's say, looks like. The inverters are connected through RS485 in a daisy chain and can connect to the EPM. The EPM can sit at a far distance from the inverters where the grid connection point is. This is very important, the location where this EPM is installed. In this case, it has to be here at the grid connection point. It needs CD clamps to measure the current for on each of the phases. If we're talking about three-phase hybrids, these CD clamps, we do not deliver them because, as you know, the size of the CD clamp will be decided by the actual value of the current, which goes through this grid connection point, depending on the size of the inverters, the number of the inverters, the size of the loads here, which can be even not only residential, but can be even on commercial sites, industrial sites. They can be very high. That's why these will have to be purchased separately by the installers. And it's nothing special about them. They only need to have a 5 amp secondary current. This is the most important thing. Otherwise, the primary current can go up to 3,000 amps. This solution also, what it brings, other than just export management, it can offer also 24-hour consumption monitoring, because this EPM here, this one is powered from the AC side, so it doesn't matter if you have or you don't have any PV generation. If you have, for example, loads that are working also throughout the nighttime, you're going to be able to measure the consumption of these loads also during nighttime. And this information can be made available on Solis Cloud app on our monitoring platform, so customers can see their load consumption 24/7, which can be very important for some. In terms of how you would connect an EPM to the inverters, I just want to mention that depending on the type of the inverters, you might have different options. So for the inverters up to 20 kilowatt, actually all of our inverters, not just those up to 20 kilowatt, but all of our inverters have this 4-pin communication port that you see here. This one has 2 pins for RS485 communication and 2 pins for a 5-volt power supply, where you can actually connect a date logger. You can power and have the inverter communicating with the date logger. But you can also use this 4-pin. You can use it to parallel the inverters together, so connecting these RS485 pins in parallel and connect them to an EPM. Because of the design of this port, you will actually need this type of adapter. It's an adapter which connects to this 4-pin, and it has 2 wires, the plus and the minus, and this one can actually be used. You have a blue and a yellow. You connect the blues together, you connect the yellows together, and you form your daisy chain, which goes to the EPM. The EPM, as I said, it will stay connected at the grid connection point. It will take its power supply from the AC side. And if it's a Solis EPM 35G, for now you will need 3-phase power supply. So you can't just start it with 1 phase, you will need all of them. So the grid port, where you will connect the 3 phases. Excuse me, my voice needs a bit of refresh. So this grid port, where you would connect the 3 phases, it will take its voltage measurement from here. And also you have the CD ports where you connect each of the CD clamps. If we're talking about EPM 3-phase, then it has the communication port where you would connect a date logger to it, and the COM-INV port where you connect the inverters in parallel. What I want to mention is that it's very important to have, for the grid port, you have the L1, L2, L3 connections. It's very important to have CT1, CT2, and CT3 installed on the same phases, meaning that you have to make sure that the sequence of the phases is actually correct, because otherwise, if you have L1 installed on L2 and L2 on L3, you're going to have a completely different sequence, and the EPM will measure wrong the power values for each phase due to the wrong phase rotation. On the bigger inverters, those from 30 kilowatt upwards, we have different type of, additionally, we have also other type of communication ports. Either they could be terminal blocks where you can connect a plus and the minus. It's in and it's out to go from one inverter to the other. Or you might have RJ45 plugs, again for in and out. Or you can have these type of 16-pin ports, and these 16-pin ports have special pins for RS-485 communication, separate one for meter connections. Make sure you check in the user manual for the particular inverter that you're using. You're going to find which type of communication port that inverter additionally has, and how these pins or ports are defined and how to use them. Now, going a bit further to the Solis Cloud monitoring platform, what I want to tell you that we're super happy now with where Solis Cloud is actually going. I think it has been developing to become a very nice product for residential, commercial, and for energy storage plants. Before Solis Cloud, we had a different type of monitoring platform, which did not allow us to do, or did not also allow our customers to do too much or to have too much control over their installations. But nowadays, with Solis Cloud, the way that we have developed it can be used by organizations, by distributors or installers, or by end users, and you can have very nice control over the installations. You have remote control functions, so you can remotely control the inverters from the monitoring platform or from the app. You can, as an organization or as a distributor, we have there this type of organizational diagrams that you can create so that an organization can have overview or have access to the installations that their other sub-organizations or installers who have their account under their let's say organizational diagram to have access to those installations. But also the end users have the option to either create their own account, or the account can be created by their installers, and they have full control over their installations. They can give access to an installer to monitor the installation for them, or they can remove access for if they don't want a certain installer to have access anymore over their installation. So quite flexible, gives a lot of options to everyone. So in order to connect,
Carmen.
yes,
Carmen,
yes.
the end user and the installer remote control is now by default. It's not by request.
Exactly. Yes, you are right. I did not I did not modify that. That is a very good remark. So the remote control, yes, it has been now granted to everyone. So every installer and every end user will have access to change settings within the inverters. And we know that this is extremely, for end customers, it is extremely important, especially if we are to talk about the hybrid installations, where customers might need to, for example, change charging times to charge or discharge their batteries on demand if they want that to. So in order to do this, to do all this, you need one of the data logging devices that we offer. Definitely for the residential, the data logging sticks are the greatest. They can connect up to 10 devices. So 10 inverters with one dongle, you can connect with 10 inverters at the same time if you connect them through RS-485. Or you can have the EPMs with the data logging sticks. And for the C&I and utility, we have other type of options. We have the S3 data loggers, which will soon come out. And also we have the PLC CCO device, which allows for inverters who communicate through the power lines, so through power line communication in the utility projects to actually achieve this. This is how, let's say, the solution for monitoring the inverters looks like. So if you have just inverters up to 10 devices, you can connect them through RS-485, and you can have a single data logger which is connected to the last inverter in the chain. And this one either depends on the data logger that you choose. It can be Wi-Fi, it can be GPRS, it can be LAN, and you can connect it to the router to get data to Solis Cloud. If you have Solis inverters with EPM 5G, the one without the internal data logger, you have the EPM and the Solis data logger, which again will connect to Solis Cloud. When you have the EPM 5G Plus, which has the internal data logger, you don't need to add a dongle to the system. It will connect through Wi-Fi or through LAN. And if you have the Solis PLC CCO, so communication through power lines, you would connect the data logger to the PLC CCO. In terms of commissioning, I'm going to go real quickly through the steps. For the grid-tied inverters, I think everyone knows that it's not much of a job in terms of setting when or it shouldn't be much of a job in terms of setting when you're setting up an inverter. The only thing you might have to make sure that you have this the correct time, the correct communication address. This is important if you are connecting to a data logger. You would want to have, when you have a single inverter, you want to have the communication address set to 1. If you have multiple inverters, of course, each one needs to have distinct communication addresses. Set the grid code, but usually if we deliver inverters in a certain country, we do send out usually the inverters with the grid code already preset. But if it's not, for example, for Sweden, can you tell me, Per, now for Sweden, what is the actual grid code that we're currently using, and it's in line with the standards, with the grid requirements?
I will write it in the chat, and it's the
Yes.
EIFSSW.
Yeah, exactly. But for each country, we have different type of grid codes. And normally, for the countries in the European Union, we have a variation for the EN 50549. which can be marked with some letters. For example, LT, this is for Lithuania, like BO for Poland. But for those countries where the grid code deviates a bit more than from the EN 50549, we have specific grid codes designed for that. The next is, if you want to set up zero export, you might have to enable those settings as well. And the last, to configure the date logger. For the hybrid inverters, of course, that's a bit, in terms of commissioning, that's a bit different. And this is because, well, usually how a hybrid inverter works, and I'm going to go through real quickly. So the hybrids will need, if they're connected, our hybrid inverter, they're connected to a battery and to a Solis meter, which measures the export and import at the grid connection point and send this information to the RS485. Hybrid is connected to, can be connected to a battery, to the PV, and also on the main AC port you would have the connection to the grid, and these are the main loads connected to. But also you have the backup port, AC backup AC grid port, where you can connect your critical loads, your backup loads, and these will be supplied power from the battery and from the PV in case the grid goes off. But otherwise, in normal, let's say we call it self-use conditions. So when you have a grid connected and you have PV that is being generated, well, normally if that PV is not consumed locally, it would go out to the grid. But the Solis meter detects that there's an excess of energy going out to the grid. So instead of letting it go more or less to waste, because we know that the prices for selling electricity are not the best, you would rather store it in your batteries and use it later. So the Solis meter detects that excess of energy, and it will take that energy and store it in the battery for later use. And for example, in the nighttime, when you don't have PV energy available and you turn on your loads, this Solis meter will detect that there's consumption from the grid, consumption of energy coming in from the grid. So that's when it will start discharge the battery so that it will cover those loads. So this is the normal self-use mode in which an inverter can work. Here you can see these are the normal. Actually, I'm going to go through the three-phase hybrid. This is the example for the RHI 3P 3 to 10K inverter. And this here at the bottom, you can see it has a DC switch, the PV inputs, the battery connections where you would connect the power cables from the battery, the CAN communication port with the battery, communication port for the monitoring portal, and ACV main AC grid supply and backup supply where you can connect those critical loads. This inverter, and actually all of our inverters, can work in these type of modes. We talked about the self-use mode, but then we have the feed-in priority mode. For example, if you want to feed the excess of PV, to feed it to the grid instead of saving it in your battery, in case, for example, you have subsidies that you can gain if you're exporting your energy. This is rarely used. There is also a backup mode where you can set a certain value of a reserve for your battery. So you will always keep a certain percentage, like 50%, 80%, keep it as a reserve in your battery, just in case you know that For example, if you live in areas where you have frequent power outages, you might always want to have a reserve in your battery. So this backup mode can work in parallel either with self-use mode and with feed-in priority. And at the same time, on top of all these, you can also set time of uses, or time charging, we call them. For example, if you know that you have lower tariffs for energy during the nighttime, you can set up for the inverter to charge a battery within that specific time frame. And afterwards, outside that time frame, it can work in the normal Celsius mode, for example. And additionally, these inverters can also work in off-grid mode, but this means that they will not have ever no grid connections. So all your loads would be connected to the backup port. In this case, you would not even need a meter because you don't have a grid to connect to, and the system will work only based on PV and on the batteries. And this is how the system diagrams for the 3-phase actually works. It's the inverter with the PV and with the battery. You have the backup where you would connect the critical loads, and the grid, the main grid power supply, main grid port where you would connect the actual grid, the meter, which is connected here at the grid connection point and measures export and import, and sends out information through RS-485 to the inverters. So it's quite easy and very, very flexible, I would say. And that's why you have to know how it works. So in terms of commissioning, you can have you know what you have to set up. Set the time, set a communication address, of course, set a grid code, just like you would do it for the grid-tied inverters. But additionally, you have the battery select. So you have to select the type of battery from the list, from the predefined list. You have to select the type of meter, if it's a single phase or a 3-phase meter that you're using. The type of storage modes, if it's self-use or battery reserve, or if you want to set up those charging times, you have to also do that. You can do that as well. And I'm not going to go through the monitoring platform steps. Now, just at the end, I'm going to share with you. Actually, I'm going to share this presentation. And within this presentation, you're going to find just the very easy steps on how to create an installer account on Solis Cloud, how to do the Wi-Fi configuration with the app. You have here some YouTube links from our Solis Europe platform, and these videos will show you exactly how to do a Wi-Fi setup, for example, either using the Solis Cloud app or just using your phone or your laptop if you don't have the app available, and all these small steps, and if also even how to create an account for an end customer if you are an installer. In terms of firmware upgrades, I need to tell you that this is available for now just for Solis engineers, but quite soon enough it will be available from the installer account as well, because for many installations like the hybrids, for example, because we're adding so many of these batteries and new functionalities also on the S6 hybrid, you might need those firmware updates. So this option will also be available quite soon in the installer accounts as well. And also for troubleshooting and replacement process, we do have throughout Europe quite a big team, support team, technical support engineers like Per here in Sweden. We have up now, I think we're 80, actually 60 throughout Europe for service. And you can get in contact with us either through the email. You can create a ticket, or you can even call the service line or access our Solis service center. And if you do encounter any issues, you should let us know. Always, when if you're an installer and you're doing a troubleshooting process, I would advise you to get in contact with us while you're still on site, or if that's not possible, just to gather all those informations that you think might be needed to, for example, to prove a fault of an inverter. For example, measurements on AC side or DC side, LED status and serial numbers, and send these inverters and these informations of the inverter, send it to our service line, on email on our service email. I will share with you right now, if you would not mind. 1 second. I will share with you this presentation. Just it will take just a bit, because I forgot to actually upload it in here. And you're going to have all this, even if you're not able to actually download it right now. You're going to be able to. I'm going to share it with you. You're going to receive an email with the actual recording of this event, so you can review it anytime you want. But also, you're going to be able to download this PDF as well. Okay, I think it's almost. Otherwise, tell me, Per, did we have any, let's say, questions that
we had some questions in the chat,
yes,
but we solved everything. I got a question from Magdalena, I think it was, that was writing. I don't know if it's your language. Magdalena Jesusek.
it might be, but it sounds a bit Polish. I'm not sure, but I will actually, let me check.
Middle somewhere.
Okay, Magdalena is typing, but I'm not able to see. If you have any questions, please don't. Okay, it was regarding the issue that Mathieu, not personally. Okay, thank you, Magdalena. Okay. But if you have any questions, straight, you can write either to me or to Per here on euservice@solisinverters.com. Yeah, and
if you're writing to me, please use the SE service.
Yes, and just write to whom you're addressing to, and those tickets, because automatically a ticket is created and they will be assigned to us.
Perfect.
Yeah. Okay. Well, thank you very much for your attendance. It was really nice being here and presenting all this. And keep close, because we're going to organize a lot of new webinars and seminars soon.
Thank you, Carmen.
Okay. Thank you. Have a nice day. Bye, everyone.
Bye-bye.